So this week was the IrMO, the Irish Mathematical Olympiad, and we did it in our school, and I know a lot of the people didn't know how to solve the questions, because even though the maths itself isn't too hard, the problems, they require you to really think about them. They're kind of weird problems, and I find that the Leaving Cert Maths course doesn't really prepare you for these kind of problem solving. It's a lot of just kind of like learning formulae and applying them. So yeah, I'm going to show you how I did these problems. This doesn't mean it's the best way to do these problems or the only way to do these problems, but this is the way I thought of doing them. So in the first problem, we're told that Mike gets paid either 40 or 70 euros every day, and he never gets paid the same amount 2 days in a row. And then during a certain time period, he earns 1,500. How long did this last? So my first instinct was to think, right, how many times he's going to get 40? Well, there's two possibilities. He's either going to get 40, then 70, then 40, and then 70, dot, 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 so on. Or he's going to get 70, then 40, then 70, then 40, dot, 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 so on. So what I thought to do is, instead of thinking of these two scenarios, another way you can think of it is every 2 days, no matter what, he's going to get paid 110 euros. So for example, in these first 2 days, that's 110. In these first 2 days, that's also 110. And it's the same down here, because they're just in the other order. That's 110. That's 110. So I thought, right, if he gets 110 every 2 days, how many times does 110 go into 1,500? So 1,500 divided by 110 equals what? So it's about 13.6. So we'll say it's equal to 13.6. Obviously, you can't have 0.6 of a day, but we have the 13 definitely. We know that 13 is going to get you very close to 1,500. So then what I said is right. So how much money does he have after these 13? It's not 13 days. It's 26 days. How much does he have after 13 sets of 110? So 110 times 13, that'll give you 1,430. And as you can see, in order to get to 1,500 from here, all you need to do is add on another 70. Because then if you plus 70 onto that, then you get 1,500. And that's it. So he gets 110 every 2 days. So he get 110 in 2 days. We need 2 days. There's 13 sets of these 2 days. So 2 days times 13, then plus one more day to get that final 70, and that gives you 27 days. And that's the answer for the first question. In question number 2, we're told about Annabelle and Bridget and their 5 sisters, and they sit on a staircase and there's 7 steps. So I will draw that out just so it's kind of easier to visualize. So that's 1 step. I'm too lazy to draw them all out. I'm going to copy and paste. 2, 3, 4, 5. Bruh. I can just do 5, 6, 7. Okay. 1 sister's on each step. Annabelle must sit at least 2 steps higher than Bridget, but the order otherwise is unconstrained. How many different ways can they be seated? So you can do this very methodically using the something choose something function, but I did it a bit more intuitively. So I said, right, so you have 2 of them and they have to be 2 seats apart. It has 2 steps higher. So how many possibilities are there for that? So first of all, assume that one of them sits at the bottom and then the next one has to sit 2 higher, so here. So that's 1 possibility, or she could sit here, 2, or here, 3, or here, 4, or here, 5. So there's 5 first. So yeah, in each of these scenarios, she's at least 2 steps higher than the first sister who's at the very bottom. Now if I just rub these out. Now another possibility is that the first sister sits here, and then the other one has to sit at least 2 steps higher. So that's 1 possibility, 2 possibilities, 3 possibilities, 4 possibilities, plus 4. And then it just keeps going. If you put her on a 1 step higher, there's going to be 3 possibilities. If you do 1 step higher, there's going to be 2. And 1 step higher, there's going to be 1. Add those all together. That is 15 different possibilities. Just talking about the 2 sisters who have to be, one has to be 2 steps higher than the other. Just considering only those 2, there are 15 possibilities. Now, along with those 15 possibilities, so I'm just going to choose a random one. Let's say here and here. That's a valid possibility. Then the other sisters can sit anywhere. So, and here's how we're going to calculate that. So now we're talking about the other sisters. I'll do this part in pink. So first of all, how many different possibilities does the first sister have? Well, she can sit in any of 5 places. So let's say maybe she sits here. So that's 5. Now the next sister, how many options does she have to sit? She has 4. And for each of the 5 first possibilities, for each of those, you can put the other sister. For each of the 5 possibilities, there's an extra 4 possibilities. So we have to multiply those. Because, for example, in this configuration right here, the 4th sister could sit here, 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 or here. So that's 4 possibilities. But then if the pink one is here, there's another 4 possibilities. So there's 5 possibilities for the pink one, and for each of the 5 possibilities of the pink one, there's a different 4 possibilities for the blue one. So we could say here. So 5 times 4, and then it just continues on. So the next one will have 3, just following the same pattern. The next one will have 2, and the next one will have 1. So, sorry, I probably should have drawn that. So maybe the next one sits here. It had 3 different possibilities, so multiply by 3. The next one has 2 possibilities, so multiply by 2. And then 1 more, and I explained the reason we're multiplying earlier. That's 120. Now, the last step is we just have to multiply these 2 numbers together. The reason for that, there's 15 different possibilities for the 2 red dots, and for each of those 15 possibilities, there's 120 different ways the other ones can be sat in each of these 15. So, for example, in this configuration of these 2 reds, there's 120 different ways for the pink and blue ones. And then if I moved these reds slightly, there'd be another 120. So there's 15 120s. So 15 times 120, that's 1,800 different ways. So the third question was actually the one I found the hardest, funnily enough, and it took me a while to get it. But basically, there are 2 ways of doing it, and I really like the way in the solution, so I'm actually going to show both. The way that I thought to do it is, if you, for example, if you were to move one of these rectangles, that doesn't actually change the perimeter. For example, if I were to move this one over to here, you can see the same sides are still pointing out. Like, you still have this left side, you have the top side, and you have the right side. So it's still the same. And when you slide it over, the area, if you slide it over to the left, the perimeter here is decreasing, but the perimeter here is increasing, so they actually cancel each other out. So you can slide these along to make it easier. So the way I thought of doing it is to have it like this. So you could have, well, first of all, we have 5 in the middle. I'll kind of use that as the basis. 3, 4, 5. Slide that one over to the side. Slide this one to here. And then we have 3. And it doesn't actually matter where we slide those, so you could even just slide them here, here, and here, as long as they're all still touching each other, because that's important. The fact that they're touching each other does give extra perimeter, because, for example, or less perimeter, sorry, because, for example, if these 2 at the top were touching each other, if they were touching each other, these 2 sides would no longer be a part of the perimeter, because they'd be touching each other. So you can rearrange it like so, and then just count the sides. So we have 1, or sorry, we can't just count the sides. We need to count, because in each rectangle, we have a length and a width. And we know that 2 times the length plus 2 times the width will be 22. Because the total perimeter is 22. So 2 of the lengths plus 2 of the widths will give you 22. That means the L plus W equals 11, if you divide the whole equation by 2. So first of all, let's count how many L's there are. So I'll use pink. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lengths. So we have 10 lengths. And then let's count the widths. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So plus 10 widths. What's that going to be? Well, we know that 1 length plus 1 width is 11. So it's exactly that, but 10 times. We have 10 lengths plus 10 widths. So if we just multiply this equation by 10, we get 10L plus 10W equals 110. And 110 is indeed the correct answer. Technically, 110 units. Because we're told that each one's 22 units. So that's the answer, 110 units. So the fourth problem is, and a few people didn't know what the heart meant in my class. The heart is basically just a symbol. So for example, when we see 3x2, we know that x symbol, that means we need to take 3 and add it twice. So 3 plus 3 and do that 2 times. That's what the x means. So this heart just is the same thing. It just means you do something. So x heart y means you do xy over x plus y. Then it says find the positive number x for which x heart 4 plus 1 over x heart 1 over 4 is 3. So the first thing we need to do is we need to compute x heart 4. And we do that using the original equation. So if we know x heart y, I'll write it out in proper maths. So x heart y, that's going to be xy over x plus y. So if we have x heart 4, that's going to be x times 4 over x plus 4, which you can also write as 4x over x plus 4. So that's the first part. Now we need 1 over x, heart 1 over 4. That means we're replacing all the x's with 1 over x and replacing all the y's with 1 over 4. So we have 1 over x heart 1 over 4. So the x is going to be replaced with a 1 over x multiplied by 1 over 4, because that's the y, over 1 over x plus 1 over 4. That can be written as 1 over 4x over 1 over x plus 1 over 4. That's a bit of an annoying fraction. So what we can do is we can multiply top and bottom by 4x, because that's the lowest common multiple of all of these. So we multiply the top by 4x, and multiply the bottom by 4x. And the reason we're allowed to do this is because we're multiplying this fraction by 4x divided by 4x, and 4x divided by 4x is 1. Because anything divided by itself, it's just 1. So if you multiply something by 1, it doesn't change. That therefore, we're allowed to do this. So 1 over 4x times 4x, that's just going to give you 1 over, and then 4x times 1 over x will give you 4, and then 4x times 1 over 4 will give you x, so plus x. And basically what it's saying is that x heart 4 plus what we just figured out will be equal to 3. So x heart 4, that's just 4x over 4 plus x. Sorry, that's bad x. And if we add that to this one, the 1 plus 1 over 4 plus x, we know that will give us 3. That's what the question's saying. Now we just solve this. If we multiply both sides by 4 plus x, so we do 4 plus x to both sides. On this side, they'll cancel with those two, and you'll get 4x plus 1 equals 3 times 4 plus x. Therefore, 4x plus 1 equals 12 plus 3x. Bring the 3x to the other side as a minus, you'll get x equals, bring the 1 to the other side as a minus, you'll get 11. And that is the answer. How can we verify that? Well, we know that if x is 11, that means that 11 heart 4 plus 1 over 11 heart 1 over 4 should be equal to 3. And I'm not going to do that, but you can try that out for yourself as practice if you want. So you just need to calculate 11 heart 4, add it to 1 over 11 heart 1 over 4, and then see if that gives you 3. As an avid cuber, I found this one to be quite easy. So we have 17 white cubes and 10 black cubes. Each one has a length of 1 centimeter. And she uses this to make a large cube of length 3 centimeters. What's the maximum value in centimeters squared of the white part of the surface area of the resulting cube? That's a mouthful. So we know that on each of these small cubes, each side will be 1 centimeter squared, because it's 1 by 1, so it's going to be 1 cm squared. And basically how this works is, on a cube there are 3 different types of pieces you could have. The first one is like, for example, this one in the middle, and that only has 1 color, as you can see. The second piece, if you imagine these as blocks, is this one, and as you can see, this is just 1 block, but it has 2 faces on it. And the final one is this one here, and as you can see, this is still 1 block, but this one has 3 faces on it. So if we want to maximize the white area, we want as many as possible to have 3 faces on them. Now if we look on a cube, they can only be in the corners, so there's only 1, 2, 3, 4, 5, 6, 7, and then if you imagine there's one on the back, there's 8. So there can be 8 corners, and each of those corners has 3 sides. So we can have 8 times 3 centimeters, we're going to have 8 corners and 3 sides, and each side is 1 centimeter squared. So that's going to be 24 centimeters squared if they're all corners. And then the next best thing we can do is have edges. So we can have these ones because they have 2 sides. So she has 17 white cubes, and we've already used 8 of those on corners, which means she can use 9 of them on edges, because she has 9 left over. And there are 12 edges in total if you count, so we're allowed to do that. So 9, she has 9 left over, and each of these edges will have 2 different sides, and then each of them will be 1 centimeter squared of area, and I'll give you 18 centimeters squared of area. Add those together, 24 plus 18, that is 42 centimeters squared of area. And the final one, I did this in a very complicated manner, but I'm still going to show what I did, because it's what I did. In the solutions, it was a lot easier, but I'll put the solutions in the description, or if you did this, you probably have them already, but I'll put them in the description probably anyway. I'm going to show you the way I did this, because that's what's important. So there's a rectangle, and it's into 4 triangles, and the area of the 3 triangles are given. What's the area of the 4th one? So I did is I drew out each, well, I can do it on the diagram actually. So first of all, for example, the height of this one, first of all, I'll number them probably. This can be the first triangle, this can be 2, this can be 3, this can be 4. So if we're looking at triangle 1, this is the height of the triangle, and this is the base. So we're going to give some labels. So this side can be the width, this side can be the length. So the area of this one is going to be width, and then I'll call this little distance here h1, okay? So I'll say that the area of 1, so the area is equal to 17, and the area of a triangle is half the base, which is w, times the perpendicular height, which is h1. Or just to make it a little easier to work with, we can say that wh1 equals 34, just multiplying both sides by 2. That's the first important equation. Area number 2, we have this one, so we can call this height, we can call this h2, I don't know. And of course the base will be L. So we'll have, and this area is equal to 16, so 16 will be equal to a half times the base, which is L, times the height, which is h2, or just make it a little easier to write, we can say that L h2 equals 32, multiplying both sides by 2. Area number 3, we don't want to introduce more variables, so if you look at the height of this, you can see it's the entire length of W, but without the h2 part. So the height of this is actually W minus h2. So the area is 22 equals a half. The base is just L, it's the same as this side on the top. And then the height is just W minus h2. Or again, simplifying that, we can say that L times W minus h2 equals 44. And the final ones is what we're looking for. Area 4, and that's x, I believe. Yep. So x equals a half. The base is just W. It's the same as the left side, W. And then the height of this triangle is the same, similar to the previous one. It's going to be L without that h1. It's the entire length of L without the h1. So we can do L minus h1. So let's just think about this. In order to find out what x is, we need something that has a W, an L, and a h1. So the problem is we don't need a h2. The h2 is just going to make it more awkward. So we need to get rid of a h2 in all of these equations. So the first equation is okay, that's just W and h1. Here we have a h2 in the second one, and we don't want that anymore. So what I'm going to do is I'm going to isolate that, and I'm going to say we can replace every h2 with 32 over L. Okay? Now we can put that into this one. We can insert that fact into this equation, and what that'll give us is we'll have L times W minus 32 over L. And that's equal to 44. Okay, so now we kind of changed some of our equations. I'm going to rewrite them out. So this first one we haven't changed. This one's still all good. So this is still an important equation. Equation 2 is useless. We've already used equation 2. We've already put it into equation 3. So this equation 2 is no longer useful. This is equation 2 now. This one. So this is our next important equation. I'll put it in white. And I'm actually going to expand it. So L times W is LW minus L, and then the over L will cancel. LW minus 32 is 44, which means that LW is just 32 plus 44, which is 76. So that can be our new equation 2. We don't need the rest. Okay. And then our third equation is what we're looking for. What we're solving for is this. So what I'm actually going to do is I'm going to expand this out, and you'll see why now. X equals a half. W times L is WL. And then W times H1 is minus WH1. And as you can see, equation 1 is WH1, equation 2 is LW, or WL, they're the same. So X will be equal to a half. Now, LW is just 76, minus, and then WH1 is 34. So X equals 76 minus 34, that's going to be 42, so it's a half of 42. And in my particular exam, I forgot to do the half, and that's the only thing I got wrong. I said 42, but it's meant to be a half of 42. That means that X equals 21. And that is the answer. Did they give us units? No. So X is 21. That's the final answer. So yeah, if you have any questions, you can comment, and yeah, hope you enjoyed.